Time for some computer science. There's 5 different types of variables that you need to know. Let's look at integers and reals.
Integers can be used to count things, like the number of ice creams I have. 0, 1, 2. Integers are great, but reals are where it's at. In the real life, we use reals. Look at my ice cream now. How would I store this as an integer? I have more than 0 ice cream, but less than 1 ice cream. So I'd either have to say I have more ice cream than I have, or round it down and say I have less ice cream than I have. This is where reals save the day. I can say exactly how much ice cream I have because reals are like decimal numbers. So I can say I have 0.66 ice creams.
There's also strings and characters. Characters are a bunch of individual letters. They can be combined to form strings. And finally, Boolean is a value that can be either true or false. And that's the only thing it can store. So here's how we'd set something to be an integer. We'd use int. So in Python, reals are called floats, so you just put float at the front. And booleans, you set them just equal to true, or you set them equal to false, and you capitalize the T of true, you capitalize the F of false. Strings are just a bunch of characters, and they're the default input. Now time for some maths. Here's some addition, subtraction. This is just division and multiplication. Let's talk about integer division.
Sometimes you want to divide things without ending up with a bunch of crumbs. So this is where you can use something called integer division. So if I wanted to split this into 2, I could do that. And then I wouldn't split the last one, I wouldn't break it in half, I'd just leave it like this. So if I did 11 integer division 2, I'd get 5. Okay? Now the opposite of this is something called modulo. Modulo basically gives you the remainder. So that's this plate here of like what's left over. So here in this example, 11 modulo 2 is equal to 1.
This is how you put something to the power of something else. So it'd always be like, this is 2 to the power of 2, and this would be 2 to the power of 3. And then when we run it, we see that that's 8 as we expect. Selection statements.
Life is filled with choices, and we can use selection statements to decide what to do. If it's sunny, go to the park. If it's raining, then stay home. No one's on the swings, go on the swings.
So here's the answer for the selection statement things. So at the end of your if statement, you need to have a colon in Python, and you also need to indent anything that is in that if statement. So when you have an if statement, you have to use 2 equal signs.
It's like the difference between going, is this a cat? And this is a cat. And this is a cat.
This is because here, this is like us saying, this is that. Because we're saying your city is that input. It's a definite thing. We're resetting your city to equal this. Whereas here, we don't actually want to change the value of your city. We're comparing it. So 2 equal signs is like if you're asking a question. Is this Glasgow? Whereas this is saying, if you inputted Glasgow, it would be, this is Glasgow. So that's the difference of that. This is the not equal sign. And if you have an else, then you have to have it in the same row, or like the same indentation as the if statement. And anything after the else is also indented. You can have ifs inside it. Else you can have like multiple if statements inside each other. So that's how you do that. Case statements, you'd have to look at a different language. You can look at Swift or JavaScript, or there's a bunch of others. But basically how they work is you have one variable. So for example, it'd be switch x, and then each time it'd be compared to 1. So is x 1, then I'd do this. Is x 2, you'd do this. So you usually use case statements because it's less code than writing a bunch of if statements where you'd have to go if x equals 1, if x equals 2, if x equals 3. That's a lot of repetition, and us programmers, we're lazy, so this is just less words to write if you're comparing the same variable each time anyway.
There's two types of loops you need to know in Python. Firstly, fixed loops. Fixed loops are used when you need to do something a set number of times. Like, look at the staircase I need to walk down. There's 5 steps I need to step down. So I can just repeat the stepping down procedure 5 times. 1, 2, 3, 4, 5.
Here's the example. So in Python, how it works is this is the start value, and that's the end value. As you can tell, this only goes up to 10 because it sees the 11 and then it stops. It never actually runs it after that 11th time. So once I is 10, I will increase to 11, and then it'll stop. It'll see this and it'll stop. So this won't happen when I is 11. So you always need to make it one more than you actually need. This is your variable type, like the variable name, so this can be anything. It can be this. You just then use that insanely terrible variable name. So make it something legible, I guess. And if you have a for loop inside a for loop, you want to make sure that this variable is different, otherwise it messes up your code. Yeah, so you can have this be a variable. Yeah, that's how you do that.
Sometimes life isn't as predictable. This is where conditional loops save the day. We can repeat something while a certain condition is being met. For example, while there's no wall in front of me, step forward. Now there's a wall in front of me, so I should probably stop stepping forward.
These are while loops. So that basically, while this is true, it will do this. And then once this is no longer true, it'll stop doing that. You can have a bunch of ands and ifs. They're basically the same cases as if as a selection statement. This thing is the same. So like you can use the same operators, greater than, less than, all that good stuff. So there's the answer for that one. Repeat until is another thing that doesn't exist in Python. It's sort of the opposite of it's sort of the opposite of it's the opposite of while statements in the sense that it will do this while this isn't true. So here, if you wanted to make it into a while statement, you just swap, like, inverse the sign. Totaling and counting is like the two most important parts of code you should probably know. It's pretty simple. So totaling is like, you sort of add up everything. So you just keep a running total. So this is like a variable called total, and it's set to 0 at the start. And then you enter your score, and then it will just add, and then it'll set total equal to whatever total was before, plus the new score. And then counting is, you just go through it, and then you just, instead of adding score, it's basically the same thing, but you add 1 instead. So here's how to do that. Library routines. Library routines are a bit like an actual library in the sense that you can go and take some code that's not yours. So like how you might borrow code at, you might borrow books at a library, you can sort of borrow the procedures or functions. So here's random, that's how you get random integers. So this is like just the range, these are parameters that you get the function. This is power, which are pretty. So this is an example of how you can do the coin thingy. Basically, I had made a list that is, or an array, that is the coins that you have available and the coins that you've used. So this is like a totaling thingy of how many coins you've used. So it goes through this list, and then it'll start here, and it will keep subtracting that coin from it until it can't do it without remainders. So this is integer division, because I don't want remainders, because it's a bit hard to play with 3/4 coins. And then that prints it, so you'd have 3 times a dollar coin, 100 times 50-cent coins. That's how you round stuff, and that's like how many decimal places, and that's the variable you're rounding. This makes a binary. This gives the ASCII value. This is like make it into a character, or like the character version of the ASCII value that you've given it. That's the hex value. Strings, you can make them all uppercase or lowercase, and you can give the length of strings. That's how you do substrings. It's basically like an array. As I said previously, strings are basically just arrays of characters. So you can, the methods and the indexes are the same. This is how you do the totaling arrays. So it's a bit like the coin one. In a sense, you have an array, and then you just go through that array using a fixed loop. And then if it's greater than 10, I put it in this large category. If it's less, it's greater than 5. So this is, because this is an elif, if it's greater than 10, it's going to be here, and then it stops. So then if it's greater than 5, but not greater than 10, it will go to medium, otherwise it's small, and then that just outputs it. Here, so this is a quite typical exam question. I always tend to look at the numbers. So here, one of the things that's wrong is it says 999, but here it says 99, so I want to fix that. Another thing you want to look at is the signs. So here this should be greater than or equal to. Here as well. So in an exam, it's usually signs or small things that trying to catch you out, so just read it really carefully. Here, as you can tell, you should spell the variable name the same, and that one's numbers, that doesn't exist. So that's the same thing there. And then because you don't want it to output 999, this is pretty useless. So you want to get rid of that. And then you can also get rid of the sign. And then that should fix your code. Now let's talk about procedures and functions.
Procedure is a set of steps. For example, walking up these steps. Nothing gets outputted, but stuff gets done.
Functions are a bit like doing homework. Your teacher gives you a parameter, like the title of the essay you have to write, and then you will return the essay you've written. You have to do work, and then you actually have to give it to your teacher. So here's the examples, here's the token procedure. So you just have def, that's how you say that something's a procedure or function in Python. Then you give it any parameters that you're going to use. So this is just a variable name. Everything's indented, and then if you have like a for loop or an if loop, then you just double indent it. And then return is how you like pass back the value. So these are just the answers. You can put this is a procedure, so you don't actually need to return anything or have any parameters, then you just put empty brackets. There's different types of validation checks, and you should probably remember what they're called. Range check, make sure that they check if something's in the range. So here's the answer to this one. Length check checks that something's a certain length. So like pin numbers is a good example. Presence check checks that something's been entered. The rest are format checks. So I think the email one is actually better as a format check, because then you could check if it has an @ symbol and like a .com or ending. But you can also have a type check. So for example, for this one, you could also have a type check to check that an integer is entered. unchecked digit is a bit harder to implement, but you can also definitely do that. Here's all the standard algorithms you should know. So then you're searching is like the easiest search algorithm there is. You just go through and go, and you basically have a for loop and you check, is that the item you want? 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 And then eventually you'll find it. So this is just outputting the location as well. It's basically the same code. Here, if you want to do maximum position, it's the same thing in a sense. You go through every item in your list, but you just want to see, is it bigger than the previous maximum value? So you start with this being the maximum, that one's bigger, so then the new maximum will be this position, so it'll be 1. And then you just go on and on. The minimum's the same thing as the maximum, except this sign is different, and then you can just change the name of all your variables to min-pos instead. Here is an example of nested loops. So you want to have these names differently, otherwise your entire code is going to be messed up. So just make sure you do that. So this is a bubble sort. So it's going to compare two and then just like swap them if they're out of order.